presentation of the simulation model. The first 1 to 50 scale proposal served as a test to assess construction feasibility. A small-scale experimental module was developed, revealing instability in the formwork, separation of the posts beneath the main beams, and an overall lack of rigidity due to the reduced scale and improvised materials.
In the second proposal, purlins were later installed with an upper offset of 40 by 40 centimeters, followed by main beams with stature brackets measuring 20 by 30. Perpendicular joists were placed on top of them, providing strength to the plywood sheet. This stage was more precise thanks to the standard measurements and the orthogonality of the elements. The initial roof design included a diagonal main beam running from the southeast to the northwest and two roof slopes supported by columns of different heights. However, the design presented misalignments as the combining thicknesses caused one slope to end up higher than the other, revealing the need of adjustments before continuing.
The final proposal was configured as a structure composed of trusses of varying sizes, arranged in a step sequence that follows the natural slope of the terrain. This strategy allowed the pavilion to adapt to the topography without producing abrupt cuts or unnecessary modifications. The structural system consists of 3 rows of trusses, each supported by 5 columns that carry the main roof beams.
To ensure overall stability, a tension cable system was incorporated, anchored to towers found at the pavilion's corners. This system complements the work of the columns by counteracting horizontal loads and preventing structural displacement. The roof is composed of a series of circular structural elements combined with a central lattice that filters light and provides additional stiffness. All of these components rest on frames positioned beneath the primary structure. Ceiling panels measuring 1.22 by 1.22 meters were installed below the circular assemblies to refine the interior finish and unify the spatial reading.
Additional towers were placed above the central row of columns to reinforce the tension system and to improve load distribution. Inside the pavilion, L-shaped walls were used to organize circulation and define activity zones. The program incorporates 6 tables for model display and 8 additional tables with seating for visitors. A small kitchen integrated into a bar area completes the interior, providing a service point for social activities. Overall, the proposal combines structural efficiency, a sensitive response to the terrain, and an interior layout designing for exhibition and public use. As conclusions, the team can assert that the creation of the model made it possible to understand the logical sequence of the construction processes, improving overall comprehension. Moreover, the development of the architectural project helped complement design knowledge with structural support principles, making the team recognize that form must always be sustained by the structure and remain coherent with it. Finally, the inclusion of finishes provided a complete view of the components involved in construction processes, as applied to the completion of a project. As for recommendations, the team found that considering the function of what is being simulated allows for an appropriate choice of scale and materials for the model. That taking measurements directly from the model rather from the drawings enables interventions that reflect real conditions, and that any deformations appearing during the sequential assembly of parts must be corrected.